All right, today we're going to talk about work. So the question is, what is work? Well, we already know that it's going to involve a force. So it is a force that causes an object to move, but the catch is it only moves in the direction of the force. So if the force is moving in one direction and the object is moving in another, it is not, nor will it ever be, work. So the hint and the key there in red is remember, applying a force doesn't always mean work is being done. The object must move in the direction of the force. Example at the bottom. So we're talking about a bowling ball. Little guy here is bowling. Work is being done because the ball is going from the hand is pushing it in the same direction that the ball is moving. The ball goes forward, the arm goes forward. Therefore, work is being done. So let's look at some examples. We have 1, 2, 3, and 4. Is it work or not work? In example 1, we have somebody moving a cardboard box. The direction of the force is forward. The direction of the motion of the object of the box is also forward. Are they doing work? Yes or no? If you said yes, you would be correct because the direction of force and the direction of motion is the same. In picture number 2, or example number 2, we have a girl carrying a book bag. The direction of the force is upward, but the direction of the motion is forward. Is she doing work? If you said no, you would be correct. The forces do not match. The direction and the motion and the direction of force are not the same. Therefore, no work is being applied. In the third example, we are picking up a pack of groceries. We are moving the force up. We are moving the direction up. So both the direction of motion and the direction of force are going up. So is she doing work? Yes or no? If you said yes, you would be correct because again, the direction of force and of motion is moving in the same way, both up. The last example is carrying the pack of groceries. She is holding it and the force is going up, but she is moving straight ahead or forward. So the force is up, the motion is forward. Is she doing work? Yes or no? If you said no, you would be correct. Noting that looking at this chart, only the force and motion have to have the arrows moving in the same way. So example 1 and example 3 both have direction of force and direction of motion arrows in the same consistency pattern. Therefore, they are the only ones doing work. So what's work? A scientist delivers a speech to an audience of his peers. Yes or no? Definitely not. A bodybuilder lifts 350 pounds above his head. He is doing work because he's lifting it straight up, going above his head, and the motion is up. A mother carries her baby from room to room. No, it's not work because while the baby's moving from one room to the other, the baby's being held, picked up is the motion, so not the same. A father pushes a baby in a carriage. Yes, it is work because the forward motion of the carriage and the forward motion of the direction is the same. And a woman carries a 20-kilogram grocery bag to her car. Not work because she is picking it up to carry it. The motion is up, but the direction is to her car. So not the same. All right, so how much work is going to be done is going to depend on two things, distance and force. The same amount of work is done to climb to the gradual incline as climbing up the cliff. You're going to end up in the same place either way. But if you notice, we're looking at different things now, okay? We have more force, less distance straight up, or we have less force, more distance if you go the long length of the triangle. So the hypotenuse side means you're using less force, but you're going to have a longer distance to go. Whereas if you go straight up the short length of the triangle, you're going to have to apply more force, but move less distance. All right, so what is the formula for work? It's very simple. Work equals force times distance. But there are some keys here that you must know. The unit of force is going to be newtons. So, force, newtons. The unit of distance is going to be meters. Distance, meters. So the unit of work is going to be Newton meters. You have to take the newtons for force, combine it with the meters for distance, and you get newtons meters as an end. Here we go. 1 Newton meter is equal to 1 joule. So the unit of work is a joule. That's a lot of information to remember. Okay? Unit of force, newtons. Unit of distance, meters. Unit of work, Newton meter. 1 Newton meter equal to 1 joule. Therefore, the unit of work is a joule. All right, calculate using the formula. Work equals force times distance. If a man pushes a concrete block 10 meters with a force of 20 newtons, how much work has he done? Pause the video, solve it, or do it mental math in your head. What's your answer? You should have in your formula work equals the force is how much? 20 newtons. The distance is how much? 10 meters. Therefore, you should end up with 200 joules of work being done, or 200 Newton meters. Checking for understanding. 2 physics students, Ben and Bonnie, are in the weightlifting room. Bonnie lifts the 50-kilogram barbell over her head, approximately 0.6 meters. Ben lifts the 50-kilogram barbell the same distance over his head. Which student does the most work? Pause the video, solve the formula. All right, they do the same amount of work. They apply the same force to lift the same barbell, the same distance above their head. So, in the end, they've both done equal amounts of work.